Hello again. The last time we looked at 4 cinnamon buns, simple CAN nodes on a network, a CAN bus network, and one input board node, 2 output nodes, and a controller. Now, one thing I didn't go into the last time is that if I actually power this off and power up the network with my finger on the trigger, so to speak, the LEDs don't go on as they're supposed to, and after a period of time they eventually go on. Now what's happening is that the underlying CAN node software, the operating system if you will, it's bundled up with an application. The input application, output application in the case of these two, and the controller application. Now those applications handle the events like a switch change. So this input application is monitoring, waiting for an event, and then it sends off a frame. The controller decides what to do in response and sends out its response and sends out a frame which illuminates the output. It changes the values of the output channels. Now all that functionality depends on a network. So when the CAN node powers up, it doesn't know whether there is a network or not. So it doesn't initialize the application, which is very much dependent on the functionality offered by a network. If there is no network, there's no point in calling the application initialization and setting up event handlers, because there's nothing to send a frame to if there's no network. So the nodes wait for evidence that there is a network, and then at that point in time they call the event handler. So if I turn it on again, the actual protocol, the underlying protocol which is running in these nodes that sorts this out, is a CAN ping protocol, which is named after the actual ping. In TCP/IP, there is a network utility called a ping, which uses the management protocol to actually contact another node on the network, on a TCP/IP network, and ask for a response. So you can ping a network node to see is it there, and you get a response, in which case you know that the network is good. So in this case we've got a ping protocol which is peer-to-peer and is implemented on 2 timers, the interval and the spread. And the interval says if there's no frame, if there's no activity on the network, so in this case with nothing happening, if we didn't implement the ping protocol, if you plugged in say a test gear onto the CAN network, you'd see no activity because there's no events. The ping protocol says if there's no activity within this duration, which is 5,000 milliseconds, which is 5 seconds, if there's no activity within 5 seconds, then send a frame, this ping frame. Now the ping frame is just a very low priority. It's the lowest priority frame you can have, which is 6FF. So it's all bits set except for the remote transmit request bit. So if there's no activity within just this duration of 5 seconds, send out that frame. Now if it's a peer-to-peer protocol, so if all of these implemented exactly the same code, then everybody would flood the network. In this case there's 4 nodes. 4 nodes would send out the same frame at the same time, causing problems. So as well as that interval, the interval of 5 seconds, we've got a spread of 1000 milliseconds, which is 1 second, and that separates or adds a kind of a duration over the 5 seconds. So the 1 second interval of a spread means that we're going from 4.5 seconds to 5.5 seconds. And what the protocol does is on power up, each one of these nodes will pick a random value between 4.5 seconds and 5.5 seconds. So between 4,500 milliseconds and 5,500 milliseconds. And whoever times out first will send a frame, the ping frame, if there's no activity. And that's what's happening when we power up the network. All the nodes power up, but they don't know whether there's a network. Somebody times out with a random value, sends a frame, and now the network, all the nodes know, oh yeah, there's a network, call the application initialization. And now we're processing events normally. Now, because it's a peer-to-peer protocol, if we all powered up at the same time and sent a ping frame, we're again flooding the network. So this is kind of, it's, the other alternative is to make this a centralized protocol. So you'd have a master, which is the only node which is responsible for sending a ping frame. Now, if I turn this off again, I've got a new version of the Cinnamon Bun with a beefier DC to DC converter, and as well as throwing in a much beefier DC to DC converter, I've added a status LED. If I can actually get this connected. So there's a status LED now on this Cinnamon Bun, and added to the code is another sysconfig option which says the ping protocol will light the status LED. So when we power up now, anytime there's a ping frame, so the network is idle, whichever one of these sends a ping frame, it could actually be this controller node, the status LED will be flashed. So if I hold this switch again and power up, you'll see a flash on the status LED, which is a CAN frame being sent, the ping frame, and then things get initialized. And if we leave it idle now, every 5 seconds or so, plus or minus, this LED will flash because it sees a ping frame on the network. Now, if I keep constantly sending traffic on the network, that ping frame isn't going to be sent because all the nodes can see there's activity on the network, so it's obvious that the network is up. So in this case, the status LED hasn't fired because there is no ping frame. But if I stop activity, one of these nodes is going to power a timeout after approximately 5 seconds, and there it goes. And you've got a status message. Now, the disadvantage of the peer-to-peer element is that nobody takes control, and we're waiting for a random node on the network to time out. So I could actually now change, I suppose I could change the protocol to be, the ping protocol could be either peer-to-peer or a centralized protocol, in which case there'd be a master and slaves. And the centralized ping controller would be responsible for sending out the ping frame if there's no traffic on the network. But then when it powers up, it could immediately send out a ping frame, so that we wouldn't have this idle time. I might actually implement that and tack that onto this video. So I'll pause there and we'll come back to this. Right, I have implemented that different form of a ping protocol. So I've now added options into sysconfig. So there's the peer-to-peer option, which I've disabled at the minute, and then there's two options, both starting with ping protocol centralized, and one's the master. One option is to be the master and implement the master ping protocol, in which case you're the node who's monitoring activity on the CAN bus. And if there is an idle period, now because we're not trying to compete with, and in a peer-to-peer fashion, we only need the ping idle interval, which is 5 seconds. So if there's only one in the centralized protocol, there's only one node that's monitoring, so it will fire every 5 seconds in this case, because we've configured that to be an interval of 5 seconds, because it's not going to clash with anything else. It should be the only node implementing a ping protocol. And the actual, if you're implementing, if the protocol is centralized but you're the slave device, you will still listen for and hear ping protocol, so you know that the network is up, but you're never going to send a ping protocol frame. So once you hear a ping protocol frame, you might light your LED or do whatever activity that indicates the network being up or whatever. That's fine, but you're not going to send a ping frame. So I've actually put that into these 4 nodes. So these 3 implement the centralized ping protocol, but they're slaves to the ping protocol, and they're not going to send any frames, any ping frames. And I put the master ping protocol, the centralized ping protocol, into the actual controller, which I suppose is a sensible place for it to go. Now, because we know there's going to be no contention, as soon as this device powers up now, it can just immediately send a ping frame onto the network. So you'll see that if I power it up, if I actually hold my finger on the button again and power it up, you'll see that it very quickly flashes once it gets initialized itself, flashes the ping frame, and then everything else powers up and knows that there's a bus to work off. And again, because there's only one frame involved now, or sorry, one node involved in transmitting ping and monitoring the network for traffic, this CAN bus, this node, the controller node, can do all that work. Now there are disadvantages to that. If in the centralized, in the peer-to-peer protocol, if for example we've got one centralized ping protocol, and this frame is this node is responsible for that. If it loses connection to the network, and it's responsible for sending out the ping frames, all these nodes now are sitting waiting for evidence that the network is there, and they're never going to get that indication that the network is there. So they're all now sitting waiting, assuming that there is no network, so there's no point in them initializing applications and start doing the functionality that they're responsible for doing. And that's the problem with a centralized protocol as opposed to a peer-to-peer protocol. You've all your eggs in one basket kind of thing. As soon as this, if we re-establish communications on the network, this guy flashes his LED. Now these guys are all happy. Oh, there is a network. Up until that point, they have no idea what they're connected to. Both sides of both implementations of the protocol, both centralized ping and a peer-to-peer ping, there's advantages and disadvantages to both. So, and probably there could be a third option that we could look at in terms of the problem is that once you've got a lot of nodes on the network, I mean, you could implement a protocol where everybody tries to send test the network by firing out a message, but then you've got a problem in that everybody's going to start clashing and sending stuff onto the network. So maybe there's a better implementation or a better protocol, and maybe we'll think about it and implement that as well. But at the minute, we just have the ping peer-to-peer and ping centralized. So a node can do one of 3 options. It can either be, it can implement ping in the ping protocol in a peer-to-peer fashion, implement ping centralized, as a master, or implement ping protocol centralized as the slave, where you're just listening for activity. And again, none of that, the only evidence you have of that is that this light flashes, this status LED will flash every so often. So you know that if you're just looking at this network and there's nothing happening, then you know, well, there is some activity. The bus is up, or the CAN bus is up. I mean, obviously when we put test equipment onto it, then we can see this frame getting transmitted, and we won't need the LED for status, and we might use it for something else. But that's it. I'll leave it there for the moment. Thanks a million for watching, and I hope that's of use to some people.